Hello everyone. So today we learn about vilsmeier haack reaction. In vilsmeier haack reaction used for formylation on electron-rich arene means K electronic ring with help of DMF and POCl3. First of all, we see a simple example of N-dimethyl aniline react with DMF POCl3 and then its aqueous work up. So we get a formylation on electron-rich ring aromatic. This reaction proceeds into two steps. First one, formation of formylating agent means our vilsmeier haack reagent by reaction of DMF with POCl3. In second step, our vilsmeier haack reagent react with electron-rich ring followed by hydrolysis to generate formyl group on arene. So now see V mechanism. In mechanism there are two steps. First step, formation of formylating agent. Formation of formylating means our vilsmeier haack reagent. So therefore we require two things, DMF and POCl3. So DMF plus POCl3. So first of all we draw the structure of DMF. DMF means N-dimethyl formamide means nitrogen having lone pair and two methyl group, and formamide means amide group with only one carbon. So that's how we draw the structure of N-dimethyl formamide. And then after POCl3, So here nitrogen having lone pair, so the lone pair shift to the nitrogen carbon sigma bond. That means now carbon having 5 valency, so this bond shifted over oxygen means oxygen carry negative charge, so we attack this bond towards phosphorus. So this bond is going to be here on oxygen. So now oxygen carrying negative charge. Now draw the structure, nitrogen double bond carbon, here two methyl groups. This carbon attached with oxygen and having hydrogen, and oxygen attached with phosphorus 3Cl, and oxygen carry negative charge, and here nitrogen have 3 valency, but here we show 4 valency, that's why nitrogen carry positive charge. This negative charge shift over this bond and Cl its departure means Cl group remove. Now draw the structure one more time. And nitrogen carry positive charge. Here this removed Cl attacked as a nucleophile on this carbon, so this bond shift towards, that's why nitrogen regain their lone pair. Now draw the structure, nitrogen attached with two methyl group attached with double bond carbon having hydrogen, here oxygen, phosphorus double bond O, Cl, and now there is attach of Cl group. Sorry, there is only single bond and nitrogen regain their lone pair. Now नाइट्रोजन देखो, अब नाइट्रोजन के पास अपनी लॉन पेयर आ गई तो वो सीधा रहेगा ही नहीं, वो अपनी लोन पेयर फिर से इस बॉन्ड में डालेगा। जैसे अब इससे इसकी वजह से कार्बन हैविंग 5 valency, so this whole group is departure and we get our vilsmeier haack reagent. There is nitrogen double bond carbon, 2 methyl group, hydrogen and Cl, and that this nitrogen is carry positive charge, and this is our vilsmeier haack reagent, and which act as a electrophile, and this is chloroammonium ion. Now our vilsmeier haack reagent is ready, so we react this vilsmeier haack reagent with our substrate, means के electron rich aromatic ring arene. In earlier example we get an example of N-dimethyl aniline. So continue the reaction with help of vilsmeier haack reagent. So now we draw the structure of N-dimethyl aniline. Okay, so here nitrogen and lone pair, so this lone pair shifts towards, so this bond shifted over here and this bond shifted over, so this is carry negative charge. And always remember electrophile and nucleophile. In any reaction we find out only two things. Here vilsmeier haack reagent is our electrophile, so this ring is now our nucleophile, and always nucleophile attack on electrophile. So now we draw the structure of our vilsmeier haack reagent. Carbon double bond nitrogen, nitrogen having 2 methyl group and positive charge, there is hydrogen and Cl. Now this bond attack towards carbon, so carbon having 5 valency, so this bond shifted over here, so nitrogen get their lone pair again and reaction carries. Now draw the structure. Nitrogen donate their lone pair, so there is a double bond, 2 methyl group, and now nitrogen carry positive charge, there is carbon attaches to methyl group, nitrogen regain their lone pair, and there is chlorine and hydrogen. So in this structure we show that the aromaticity of the ring is lost, so this is very unstable. So first of all the ring wants their aromaticity back, therefore we clearly saw 1 2 3, so there is one hydrogen over here, so this hydrogen leave and get their electron towards, so this bond going to be here and nitrogen regain their aromaticity. It means by removal of one H plus ion, ring regain their aromaticity and nitrogen regain their lone pair, hydrogen, chlorine, nitrogen, methyl. Now reaction carried out forward. Now draw the structure. Now we clearly saw there is a nitrogen having lone pair, और हमने आगे भी डिस्कस किया था कि नाइट्रोजन के पास लॉन पेयर होता है तो कभी सीधा रह ही नहीं सकता, तो ये अपनी लॉन पेयर फिर से यहाँ पे डालेगा जिससे ये Cl रिमूव हो जाएगा। हमने अर्लियर देखा था कि एक H प्लस रिमूव हुआ था और यहाँ से क्या रिमूव हो रहा है Cl, दैट मीन्स रिमूवल ऑफ HCl, एंड वी गेट अ स्ट्रक्चर ऑफ the removal of Cl, therefore there is a double bond between carbon and nitrogen, and there is 2-methyl group. Nitrogen having 4 valency, therefore they carry positive charge. Now the second step, aqueous workup, means H2O. So oxygen having lone pair here, and this lone pair attack to this carbon. So now carbon having 5 valency, so this double bond shift toward here. In this case, nitrogen regain their lone pair, and we draw the structure. Nitrogen to methyl group, this carbon having hydrogen, and here attachment of H2O, means oxygen to H plus. Nitrogen regain their lone pair to methyl group. Okay, here oxygen having 3 valency, that's why they carry positive charge. So here we show a proton transfer, means K plus or minus H plus. This proton donate their electron toward here. So oxygen having 2 valency and their lone pair, and this hydrogen attached with this nitrogen. So there is, means K proton. First of all, proton is minus, then after proton add toward to the nitrogen. That's why we written like this, and that phenomena is called proton transfer. This is called proton transfer. So finally we get this kind of structure. Aromatic ring, nitrogen to methyl group is hydrogen. Oxygen now having only one hydrogen in their lone pair. Here nitrogen having 2 methyl group, and this hydrogen. Okay, here nitrogen having 4 valency, therefore that's why they carry positive charge. Now this oxygen donate their lone pair toward here. So carbon carry one more time 5 valency. So this whole group is departure, and the structure is look like this. Now nitrogen having 2, carbon having hydrogen, there is double bond oxygen and oxygen. Now oxygen carry positive charge by simply this H plus is going to be here. हमेशा याद रखना H प्लस ही वो सबसे बड़ा बलिदान देने वाला है, वही अपना बलिदान देके चला जाएगा. मीन्स कि H plus is removed and we get our final product, and that is our formation is done over here, and we get this product with one byproduct, this byproduct. So in this way we learn about vilsmeier haack reagent. I give you some example to solve by yourself. So first example is this is phenol, and the reaction with DMF first, PureCl3, and then after aqueous workup. So we get two products. First, formylation take place on ortho position. In second product, formylation take place on para position. Okay, so you solve this example by yourself. Now we see some 5-member heterocyclic ring, means that there is a 3 main kind of 5-member heterocyclic ring. This one is pyrrole. Similar one having oxygen is furan, and third one having sulfur is our thiophene. Pyrrole, furan and thiophene. And when we react with DMF POCl3 and then after H3O plus means aqueous workup means vilsmeier haack reaction. So in all this case we get formylation on second position, means here there is first, second, second, means here, because we saw the resonance structure of there is pyrrole, the lone pair is shifted over here, so this double bond going to be here, and here it's create negative charge, and this act as a nucleophile, and this attack on our vilsmeier haack reagent. So the formylation take place over second position, first, and this is second. This is also called second position if this kind of position, if we have this kind of any structure, there is any bulky group, so the formation take place here, this second position. Okay, now another kind of example is indole. Another heterocyclic ring is indole. In indole, this is the structure of indole. And when we react with our DMF POCl3 and then H3O plus, so we get formylation on third position, means the final product look like this. So the reaction take place on 1, 2, 3 on third position, because the resonance structure is look like this. This lone pair is going to be here, and there is generation of negative charge, so this negative charge attack on our vilsmeier haack reagent, and formylation take place on third position. Now see a amazing kind of example, a combination of these two, indole and 5-member heterocyclic ring, both are combined example. So in this case formation take place on both sides. If we take axis of this reagent, means if we get in axis these reagents, so we having in third position of formylation, and over here one here, and over here this second position, because this second position is now blocked, so this kind of formylation. But if we have only one equivalent, so formylation take place only this indole ring, because indole have more reactivity than 5-member cyclic ring. Okay, so this is the main applications of vilsmeier haack reagent. I hope you understand very well. Thanks for watching. Jai Swaminarayan.